Hi everyone, greetings from Mentormatics. My name is Rini Thomas and I am really pleased to be your instructor for this course. Let me first give a brief introduction about myself. As a student, you might want to know who I am and whether I am qualified enough to teach you this course. Regarding my educational background, I have a Bachelor of Engineering degree in Computer Science. And regarding my professional experience, I have around 17 plus years of professional experience working in many multinational companies in India and abroad. I have worked on many real world applications and projects and worked mainly on technologies like C Sharp, Microsoft ASP.NET, and Node.js as backend, and HTML, CSS, JavaScript, Angular, and React as frontend. Also, I have worked as a corporate trainer, training many freshers after they have been hired and making them job ready. Okay, that's all about me. Let me see you all in the coming lectures. Thank you. Welcome to C Sharp Advanced course. This course is for those who want to extend their C Sharp skills to an advanced level. Chances are that you are familiar with the basics of C Sharp and are hungry to learn more. Or you have been out of touch with C Sharp for a while and you are looking for a quick course as a refresher to get you up to speed with advanced C Sharp constructs. If so, then this course is for you. In this course, I will be teaching you the language features which will help you in building real-world applications. Whether you want to use mobile apps, desktop apps, games, or websites, these are the language constructs that you need to master. Language constructs such as link, lambda expressions, events, delegates, extension methods, nullable types, generics, exception handling, async await, and more. With hands-on exercises and real-world examples, you will be equipped to tackle complex programming challenges with confidence. Whether you are looking to expand your career opportunities or deepen your expertise, this course is for you. This course begins with an introduction to generics, a feature that allows you to create classes, methods, and interfaces that work with different types. You will learn about generic classes, interfaces, methods, constraints, and covariants and contravariants. You will also learn how to use generics to create type-safe collections and algorithms. Next, you will learn about delegates. Delegates is a powerful feature that allows you to create and pass around references to methods. You will learn about delegate syntax, types, multicast delegates, anonymous methods, and lambda expressions. You will also learn how to use delegates to implement events and callbacks. After that, you will learn about events. This is a mechanism for notifying other parts of your program when something happens. You will learn how to declare, raise, and handle events, and how to use events to implement the observer pattern and other design patterns. Then you will dive into lambda expressions. This is a shorthand syntax for creating delegates. You will learn how to use lambda expressions to write concise and expressive code and how to use them in link queries and other contexts. The course then covers extension methods. This is a feature that allows you to add new methods to existing classes and interfaces. You will learn how to declare and use extension methods and how to use them to write fluent APIs and link query operators. Finally, you will learn about LINQ, Language Integrated Query. This is a powerful feature that allows you to query and manipulate data in C#. You will learn about LINQ syntax, methods, and expressions and how to use LINQ to query databases, collections, and other data sources. You will also learn how to write your own LINQ operators and extend LINQ to support custom data types. Throughout the course, you will work on practical exercises and real life examples, building up your skills and knowledge of advanced C# topics. So, if you want to improve your C# skills and become a better developer, go ahead and enroll in this course. I hope you will enjoy this course and see you soon in this course. Thank you. Hi everyone. Today we are going to learn about the C# topic generics. Before we start with generics, let me first explain what problems generics came to solve. In .NET version 1, we didn't have generics. Let's say we want to create a list to store a list of numbers. This is a simple and basic implementation of a list. We could have a method called add to add a number to the list and an indexer that returns the number at the given index. Now, of course, there are more methods like remove and find, and I'm just removing that for simplicity here because the intention here is to talk about generics and not data structures. Now, if you want to store books in a list, obviously this class won't work. So we have to go and create a class like this called a book list with a method called add. A parameter called book is passed to this method and a similar indexer. Now the problem here is for every type we have to create a separate list, and this is a lot of code duplication and it's not productive also. Plus if there is a bug we have to fix it in multiple places. So one solution to fix this is to use a list of objects. So instead of a specific class we have a generic class where it can accept a general object, something like this. But because the object is the parent class here, for every type in .NET, we can easily pass any type to this method or get any object from this indexer. But there is another problem here. The problem is performance. If we use this class for storing value types like integers, every time we insert a value type inside the list, it has to be boxed to be stored to this object. And every time we access that value, it has to be unboxed. And this has a performance penalty. Or even if you use a reference type, every time you want to cast an object, let's say a book to an object or vice versa, this casting again has a performance penalty. So generics came as a solution to this problem. With generics, we create a class once and reuse it multiple times, and it doesn't have performance penalty like with the object list here. So let's say how we can create a generic list. Let me add the generic list here. So similar like what we have written earlier, we write public class generic list. This is of type T, specifies a particular type. And then inside the class, we have the same method, add method. So public, it returns void add, and it takes the type T as the value parameter. Also, we have the indexer. We write public, and the return value is of type T. So here, what we have done, we start with the public class. I call it the generic list. Now, generics have a parameter, and parameters are specified with angle brackets. So, like this, we usually call them T as in short for a template or type. Now, we created our add method. Instead of getting a book or a particular class, we would get a T. Then, what is this T? We don't know it. What is this T? The consumer of this class will specify that, oh, what is this T? This I will show you in a second. Similarly, To get the object from a given index, we return this value t. So that's all we have to do. Now let's see how we can use the generics. We go to a program.cs. So here you are extensioning a book object. You are extensioning a list of numbers as you see here, and you are extensioning a list of books. Now note that the problem here is that we have two different type of list. Now we can simply use our generic list we created earlier instead of these two different classes here. So let me comment out this code first. And here I will write where numbers equal to, I'll create a new generic list here. And this is of type integer. Now to this list, I can add an integer value. Similarly for books, I'll create a new generic list of type book and then books.add of book. This class we had created in the beginning of the class. So this is the way we use the generic list. Here, see in the code, we get the code reusability and we don't have that performance penalty. Why? At runtime, our generic list is actually a list of books. It is not a list of objects. So there is no casting or boxing here. So this is the basics of creating a generic list. Hope you all enjoyed this lecture on generics and thank you for watching.